Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. Integrate the following with respect to x. We have root x divided by 1 plus root x, right? So what we've been given is dy by dx and we've been asked to find y. So my y is nothing but the antiderivative of the given expression and we can represent it using the integral symbol. So let's write down our y. That's our y, integral of root x dx divided by 1 plus root x. I know that my y is not in a simple format whose antiderivative I know from first principles or any of the identities that we have learned so far. So how do I simplify y for me to integrate this further, right? So let's give it a thought. We have root x in the numerator. We have a 1 plus root x in the denominator. So as a first step towards my simplification, let me do 1 plus root x equal to t. So that's the substitution I'm going to make. T equals 1 plus root x, which means my root x equal to t minus 1, right? Now I differentiate on either side, which means that I try and arrive at what is my dt by dx, which means my dt by dx equal to 1 by 2 root x, right? So what is my dt from this particular expression? My dt will be equal to dx by 2 root x, right? So let's write that down, right? So now I go back to my y and see if I can simplify my y with the substitution what we have made, right? So I've got integral of root of x dx divided by 1 plus root x, right? So what is my root x? My root x is t minus 1, right? I hope you folks are with me. Take a look at the yellow expression what I've highlighted. So what is my dx in terms of t, right? So I have my dx equal to 2 root x dt, right? And I go back to my substitution. I notice that my root x equal to t minus 1. And if I want to represent my dx in terms of t, and I can replace my root x with a t minus 1, right? So my dx becomes 2 times t minus 1 times dt, right? Therefore, my expression above becomes, that's my y now. I'll take a minute to explain how did we arrive at this. My root x equal to t minus 1. Look at the term what we have highlighted in yellow. And then I have my dx equal to, I'm going to highlight this in green, right? We worked that out just now. My dx equal to 2 times t minus 1 dt, right? Right? And then the denominator, I have it as a 1 plus root x, which I originally substituted as t, right? Therefore, my y becomes 2 times t minus 1, the whole square, times dt, the whole divided by t, right? Now I'm going to expand using a minus b the whole square formula, and then I'm going to decompose this entire y and then apply some rule to solve this particular integral, right? So when I expand t minus 1 the whole square, what does my y become? So that's my y, because my t minus 1 the whole square is nothing but t square minus 2t plus 1, and I have that in the numerator, and then I have a t in the denominator. We also have a 2 along with us in this particular expression, right? So I'm going to pull out that 2 and rewrite this particular expression as 2 times integral of t square minus 2t plus 1 divided by t times dt, right? So that's our y. Now you look at this, it becomes a lot more simpler because I'm going to decompose this. I have a t in the denominator, and then I have a t square minus 2t plus 1 in the numerator. So I'm going to rewrite this as, so that's my y. My first expression, which is t square, when I divide it by a t, I get a t, right? And then my second expression, which is a minus 2t. When I divide it by a t, I get a minus 2. And my third part of the numerator, which is 1, when I divide it by a t, I get a 1 by t, right? So my y becomes 2 times integral of t minus 2 plus 1 by t times dt, right? Now from here on, I'm sure all of us are familiar with how to go about solving this particular problem. I apply the sum rule and rewrite my y as follows. So that's my y. My y equals 2 times integral of t dt minus 4 times integral of dt plus 2 times integral of dt by t, right? Now we are quite familiar with the integral slash antiderivative of each of these expressions, what we have as a part of y. The first part, which is integral of t dt, becomes t square by 2. And then I also have a 2 in that particular expression. So I have 2 times t square by 2. So that becomes a t square. And then I have a minus 4 times integral of dt, which is nothing but minus 4t. And then I have a plus 2 times integral of dt by t, which is nothing but plus 2 times ln of mod t, right? And then we combine the constants of each of these integrals and represent them as one single constant, right? So this is what we get. Y equals t square minus 4t plus 2 times ln of mod t plus c, right? Now I know that I cannot leave my answer in the form of t. I'll have to rewrite everything in terms of x. I know that my t is equal to 1 plus root x, right? So that's the original substitution that I had made. So I put back my t as 1 plus root x to arrive at my final answer. So there we are. That's my y. 1 plus root x the whole square minus 4 times 1 plus root x plus 2 times ln of mod of 1 plus root x plus c, right? Let me highlight my final answer in pink. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.